And here with us today, we have Scott Smith, who is a NASA nutritionist. He's here to talk with us a little about not one, but two experiments that are currently undergoing on the aboard the International Space Station with the crew members there. One of those experiments is known as nutrition, that actually looks at how our body changes in the microgravity of space, and also ProK, that looks at diet and how that diet can actually mitigate bone loss. Welcome, Scott. Thanks for coming.
Thanks. It's great to be here.
So let's start now just talking about nutrition first. I understand that nutrition has actually been one of the studies that's been going on for now quite a while, since Expedition 14.
That's correct. We started back in late 2006 on Expedition 14.
Okay, and so just walk me through what exactly is nutrition and what are we doing with that?
Well, the premise behind the nutrition experiment was that when we'd launched equipment aboard the space station that allowed us to collect biological samples. That is, we needed a centrifuge to spin the samples and process them, and we needed a freezer to store the samples for long periods of time. The question then became, what would you do? And what we first set out to do was to better understand how nutrition changes over the course of spaceflight. Mm-hmm. We had collected a lot of samples before and after flight. But with samples collected before and after flight, you don't know how you got there. So if you see a significant drop in the measurement of something after flight, you don't know what that change looked like over the course of 6 months.
Okay, so we start with something, a baseline first before flight, and then that way we can measure the differences in space as well.
That's correct.
So explain to me, what are we measuring?
What we do is we collect blood samples and urine samples before, during, and after flight, and we measure probably 40 to 50 different things in those samples. We look at a number of nutritional markers, things like vitamins and minerals. We also look at a number of hormones and regulatory factors. We're also looking at things like bone markers that tell us about what's going on with bone and muscle and other systems.
Okay. And so when you were talking about, you said blood and urine, do we do any body mass measurement? I do see some of that. I don't know if that's involved in this study at all.
We do indeed share those data. The body mass data are obviously an important picture of what's going on with nutrition overall, but clearly the goal of this experiment, if you will, is the blood and the urine.
Okay. And is there any, so I know, again, we're talking about blood samples and urine samples. Are there any other variables that we're looking at that may help give us more information for this particular study?
The other thing we try with this experiment is dietary intake. And the crews fill out, nominally, they fill out a food frequency questionnaire once a week that allows us to track dietary intake of key nutrients. That's what we call an operational protocol, where we report back to the flight surgeon, usually that same week, of, look, so-and-so's not eating enough or not drinking enough, so that we can make those changes real time.
Okay.
And then looking at those data become very important in terms of understanding. We know what the dietary intake was, but we also then need to look at how the body is handling those nutrients.
And what are we hoping to accomplish from this study?
Well, there's a lot of things. In short, we're trying to understand the nutritional needs of the body during spaceflight. Mm-hmm. Long-duration spaceflight is a challenge, and just like I always go back to the sailing missions when we first left Europe. When you're on a ship for a long period of time, you have to make sure that you have the nutrition exactly right. Scurvy is a great example of a disease that occurs when you don't get enough vitamin C. Mm-hmm. And if you look back again through history, that ravaged crews. And what we need to make sure is when we send crews off the planet for 6 months, that we send them up there as healthy as can be, and we keep them there. But even more important, when we look to send folks off to other points of exploration, making sure that we know what their body needs, the food has the right things in it, is going to be very, very critical to make sure that we keep the crews healthy and bring them home healthy.
It sounds to me like I need to go to space, because I probably would come back healthier.
Well, it's funny you should mention that, because there's many crews with the exercise protocols we have on board right now, right. And with good dietary intake, we have seen a number of crew members who literally have come back in better shape than they went. So
wow. I need to go to space.
It's not easy. It's not easy, but it can be done.
Well, they say you are what you eat. So we're going to move on to ProK. So basically, we're looking at a big bowl of queso and a piece of chocolate cake. No, But in all seriousness, the Pro-K is actually looking at how diet and what we eat can actually help mitigate bone loss. So it's not only the exercise on board the station, but it's also what we're eating. And I originally would think, calcium when I think bone loss, but that's not really what this is it?
That's correct. And folks have looked at calcium, and as I would say, the easy answers didn't work, that providing extra calcium
Sure.
won't fix bone loss during flight. We do make sure the crews get enough calcium because calcium is important, but that's not the only trigger. And what we found in ground-based studies is that the ratio of different nutrients in the diet can affect your bone response. And what we're testing with Pro-K is just that. And what we're looking at is the ratio of animal protein in the diet to the amount of potassium in the diet. And what happens is that ratio affects the acid-base balance in your diet. That is more animal protein, more red meat will lead to more acid when it's broken down in your body. And that acid, the way your body protects yourself from that acid is to break down bone. And there's a couple ways you can counteract that. One is by consuming less of those acid-producing components. The other is to consume more base-producing components. And those are things we find in like fruits and vegetables. And those are foods that are rich in potassium, which is why we use potassium as the other half of that equation.
Okay, so protein, potassium, Pro-K.
Absolutely.
Got it. Okay, so in this, are there any supplements involved, like vitamins or anything like that, or is this strictly diet?
This is strictly diet, and what we're doing with the Pro-K experiment is for 4-day sessions, we work with the crews ahead of time to plan out a 4-day menu that is either high animal protein to potassium ratio or low. And they'll consume that diet for 4 days, and then at the end of those 4 days, they'll collect blood and collect urine samples that we will then look at to see how those markers are affected.
I think we have a couple of photos. We can throw these up here now of Don Pettit, who had been participating in the Pro-K and the nutrition. There he is here. And he is actually working, it looks like he's got a couple of samples in his hand, and he's putting it into the minus 80-degree laboratory freezer.
That's correct. And yes, in his left hand there, he's got gloves on because that freezer is very cold. It sits at about minus 96 degrees C, even though we call it the minus 80 freezer. And that mesh bag there has syringes that have small amounts of urine in it that he took from his last urine collection.
And then here's just another image of some more sample.
That's correct. I think that one is actually a step before, and you can see him putting the syringes into that mesh bag.
Oh, I see.
You can see in the bottom left corner there, the door to the Melfi is open, and what he'll do is pull out one of those, what they call dewars, one of the drawers in that freezer, and those samples will go in there and wait until they bring them home.
Okay. And again, the Melfi is the minus 80-degree laboratory freezer that is used to store biological samples, such as what he's doing for this study, that require refrigeration for return to Earth for later analysis. When they are returned to Earth, those samples, they are actually brought back here to Johnson Space Center. Is that correct?
That's correct. Ultimately, they're analyzed. Most of the analyses are done in our lab, in the Nutritional Biochemistry Lab here in Houston.
Okay.
And we, up until now, we've brought all our samples home on the shuttle. So we've sent folks in the team out to the landing sites to retrieve them when they're demanifested from the shuttle after the crew. And then we bring them back here as quick as we can.
Okay. And so talk to me a little about what can you tell me about the findings from either one of these? And I know that there is also a blog, and we can put that out here for you as well. Go to blogs.nasa.gov, and you can check out the a blog that this here is When Finding Nothing Means Discovering Something. It was a blog about some of the findings. I think this is the most recent entry that was made about these studies. But go ahead and talk to us a little about some of the findings that you guys are.
Well, the Pro-K experiment first is a little bit newer, so we don't have any published findings from that just yet. The nutrition experiment, though, as you said, we've been doing that for several years, and we've had a number of key findings so far. The blog you pointed out there talks about two things that we found that didn't change.
Okay.
One of the things that we found that didn't change is vitamin K, and the other thing that we found that didn't change is testosterone. And the reason both those findings are important is that earlier studies and earlier related studies had suggested that both of those things might serve as viable countermeasures for bone loss during spaceflight. And what we found in more detailed studies with more subjects flying on long duration missions is that neither of those things change. And what that tells us is that we don't need to pursue giving vitamin K supplements to counteract bone loss, for example, or injecting people with testosterone to stop muscle loss, for example. And what it tells us, it helps us drive where to go next. So even though technically we didn't find any change during flight, in this case that's very important and very good news.
Well, that's very fascinating. And actually, it seems to me, I mean, I can't imagine how we can't get any of these findings wouldn't actually apply to us here on Earth.
Absolutely. And which leads into one of the other key findings that that we've reported on is that we found a significant relationship between the amount of fish people consumed on orbit and the amount of bone that they lost after flight. And what we found is that the crews that ate more fish lost less bone. And the reason we think that is, we think there's a few things there, but primarily the fish are rich in omega-3 fatty acids, and we've done other studies on the ground, both bed rest studies with humans. We've done cell culture studies to show that omega-3 fatty acids can help to reduce bone breakdown. And what we found in the astronauts is that, again, if you eat more fish, it will reduce bone loss during flight. And the implications for that for people, for everybody here on Earth, are obvious. So it.
For those who are not fish eaters, can they take the supplement?
That's the first question I always get, and the short answer is we don't know yet. And I think somewhere there's got to be a middle point, but it's important to also realize that when you're eating fish, you're not eating something else, which gets back to the red meat thing.
Right.
So, you know, as a nutritionist, we always push that if you can, having a good diet is better for you. The idea that you could eat a bad diet and take a pill and that'll fix it, while that tends to be what most people would rather do, the body doesn't work
it's
that
just
easily.
Like taking the pill and not exercising.
Absolutely. It's not as easy as it sounds.
Okay. Well, thank you so much. I think that's all the time we have today, but I really appreciate you coming over and talking with us again. This was Scott Smith here with us today here in the International Space Station Flight Control Room with the Orbit 2 team who is overseeing the activities aboard the International Space Station. Scott, thank you very much for coming today.
Thanks again. My pleasure.